it important? And we at OdinSchool, we are a technology upskilling platform, and we help you continuously acquire new skills and thereby stay skilled and stay ahead. And guys, my name is Varun, and I come with an experience of 7 years. I work as a developer and a trainer, and over these years, I've gained knowledge on HTML, CSS, JavaScript, R, machine learning, Python, and other languages. So, going forward, the agenda of this session would be to understand data visualization, types of plots, and then we would be moving on into a bit of Python. We would be moving on into hands-on, and let us understand how do we work on Matplotlib, which is one of the most important library for Python to work on plots and graphs. All right, so let us go ahead with the subject. So here, as you can see, in data visualization, let us start with the first topic. The first topic is trying to, or what is data visualization in first place, correct? So to begin with, it is trying to understand a data by replacing the textual or numerical content with the with info, with graphical content, or probably with visualization content is what you can say. All right. Now, when we talk about visualization, or when we talk about Matplotlib, this is one of the most important libraries that we begin with when you want to work on data visualization, right? And also, when you're working on any plot or any graph or probably anything, there are not, it is not just replacement of numerical data, but it is also finding a lot of finding a pattern, the trend, or probably the correlation, understand how is one variable performing against another, wherein when you work on, machine learning algorithms like linear regression, it becomes very important for us to start with understanding if your data is linearly arranged or not, after which you would go forward. So this is one of the very important why we, why we have to understand. So here, as we can see, this is a 2D plotting mechanism. Wanted to see yesterday, we'll look at Spider as well. And then here, as you can see, the most important library is Matplotlib, and we were talking about it. So let's. All right. So here, this is one of the most popular, and also it is very famous as a 2D library. All right. Then going further, it is very widely used library, also, widely used and popular are almost the same thing. And then it's got great support from Python community. That is the next thing. All right. And also it can be used in Python scripts, and there's a lot of things. It can generate different kinds of plots like bar chart, histogram, power spectra, scatter plots, pie charts. So guys, there are a lot of charts that we use for different purposes, so you could use them any of these. Now when you talk about Matplotlib, it basically starts with HTML5 support libraries. So talking about Matplotlib, just to let you know, it starts, or it depends on HTML5 libraries. All right, and it's also great when you would want to develop a GUI toolkits, for example, Qt or GTK. They all work on the same thing. Then the next one, as you can see, is Pandas Visualization. Well, it is built on Matplotlib, and there is not much to talk about it. The next one in order is Seaborn. Now, Seaborn is a library that is based on Matplotlib. Now, this is very important for you to understand, guys. A lot of times, if you're just using Seaborn without Matplotlib, then you might have an error, and this is an error that a lot of developers might have faced. All right, and this error is because whenever you work on Seaborn, it is because it's dependent on Matplotlib. You should have Matplotlib as well. Okay. Now, when you talk about Seaborn, it is very tightly integrated with PyData stack. All right. So let me write it down so that you have an understanding. It is very tightly integrated with PyData stack, and it also supports a wide number of libraries. For example, NumPy and Pandas are also supported because of this. All right. Now going forward, now what is the difference between Matplotlib and Seaborn? Seaborn basically aims to make visualization the central part of exploring, and also Seaborn is a bit advanced as compared to Matplotlib. Now, when I say advanced, you could use some effects, or probably you could use it for semantic mapping and statistical aggregation to produce informative plots. All right, so this is where it is useful. The next one that we have is ggplot. All right. Now, ggplot is a library which we use in our language, and so is Plotly. Now, when we talk about ggplot, GG is grammar of graphics. Okay, so I think it's already written here. It is grammar of graphics, and it takes care of almost all the requirements, just like Matplotlib. You can use great features. You can come up with almost all sorts of plots and maps using ggplot. Now, when we talk about Plotly is when you want to have interactive maps or interactive plots. All right. Then next is you have Bokeh. Bokeh is also a very important plot, or very important library. And Bokeh is based on, again, grammar of graphics, but unlike ggplot, it's used in Python. All right. And its strength lies in the ability for two things. Firstly, it's interactive, and secondly, it has web ready plots. All right, and it can easily have outputs like JSON or HTML documents also. So this is where this has a bit of an advantage. Then the next one is PyGal. You also have Geoplotlib. Geoplotlib is very important for all those for all of those people who work on spatial data, mainly on something to do with maps and all. Then when you talk about PyGal, which is this here, where did it go? Yeah, this is also a very important library. All right, now this you can say is, it offers interactive plots, and it can be embedded in web browsers also. So PyGal and Bokeh almost work like the same. Then you have missing numbers, which is very easily understood by the name itself. Then you have leather, which is the last one here, as you can see. This is also a very important library, and it's a charting library mostly. Let me charting library mostly, and this is used, or this is designed for almost all kinds of data, and you can scale them without losing the image quality. And this library, which we're talking about, leather, is a bit new as compared to the rest of the libraries. All right. So this is an understanding about the different kinds of libraries. So here we have touched base upon a couple of libraries on Python and a couple of libraries on R. And the most important in Python are Matplotlib and Seaborn. And the most important in R are ggplot. We have ggplot too, which has come up, by the way. You have Plotly, and we'll look at some more as we head on to R, probably in the sessions to come when we work on R. But currently in this session, because we're focusing on Python, let us understand Matplotlib and Seaborn. But initially, Matplotlib will be given the first priority. Now, talking about the different types of graphs we have, let me just take you forward. Now guys, here I would want you to pause the video for a second and just identify if you can understand what are the different types of graphs they are, and probably also answer in the comment section below about how different graphs are different from each other. All right, if you could just tell that, I think it would be very nice. Now, it is just a basic understanding of what is what. Now, just to give you an overview, let me just write down some very important graphs, or charts that we use. To begin with, the first one we have is a bar graph. All right, we have pie chart, we have line graph, uh, we have histogram. All right, so let us focus on probably these three or these four in the first, and then probably we can move on to the next. Now, when you talk about bar graphs, they mostly show numbers that are independent to each other. All right, guys, here you can take examples like, how many people are coming to a hotel and eating or something like that. Now, the second one, when you talked about, you have a pie chart. Now, pie chart is a circle, and you can divide this into number of portions. All right, now this is what is a pie chart. Now you can calculate pie chart when you would want to calculate the budget of an year, probably. I'm just giving you random examples. There are a lot of other reasons you could use this for, but this is just, and so you could, so this is not the budget, it is to check the budget split of an year. So I have spent 30% on advertising, 10% on something else, 18% on this, 25%. So the total would come up to 100. All right, I'm not sure of the calculation though, so please don't go by the math, but otherwise the total has to sum up to 100. And this is a budget split of an year for any financial, or for any organization rather. So this is how we can use pie chart for. The next one is line graph. Line graph I think is the most basic graph that we all might have worked on in our schooling. This is, probably an example of a line graph. All right. So this is your x-axis and this is your y-axis. All right. And line graph is used generally to identify trends or probably patterns in your data set. All right. These are the most important identifying trend is the most important reason that you use a line graph for. And that is the reason why we use this in, linear regression. And also we use line graphs to check if there is any trend in time series. So yes, these kind of graphs become very important for us to understand. Now, going forward, when you talk about uh, you know some more graphs like a histogram, all right, a histogram is a specific type of a bar chart. All right, so oops, I think a histogram is a specific type of a bar chart. Now, a lot of times we get confused. We probably identify all of them to be different, but then histogram falls as a subcategory of a bar plot or a bar chart. All right, and also when there are when the categories are ranges of numbers, you could use histogram, and in that case histogram would fit best. Probably you could consider a small example. When we talk about a histogram, I have age on one side and I have people on other side. Now when I say people, that is number of people. Now here you can classify different ages like 10 to 20, 30 to 40, 40 to 50, and you can say that for in the age group of 10 to 20, you have 3 people, you have 10 people, you have 25 people. Now based on this, I can say that this is a place which best suits people of above middle or above young generation. Now this is an example of histogram. Just like histogram, the next one that we would want to talk about is a pictograph or a pictogram. Here you can see what is a pictogram. All right, pictogram is generally used to show the number of people in each category. All right, so here you can assume this to be in the age group of 5 to 10, 20 to 30, 40 to 50. All right. And this is the intensity. All right. And now we can assume green to be, probably very high or green to be very low. Now that depends. All right. So these are the different kinds of basic graphs that we have when you talk about each of them, or when you talk about different varieties. Now here, the next one that you have is a bar graph. right? Now, when you talk about a bar graph or a dot, sorry, now this is a scatter plot. The name might be a dot bar graph, but it's a scatter plot. Alright, scatter plot in technical terms, it might be a dot bar graph as well. Now, scatter plot is generally used to identify the error distribution, okay, or probably it's used to check the linearity trend. So guys, the most important takeaway here is when you're looking at in any of these plots or any of these graphs, it does not narrow down our thoughts, or probably it does not narrow down to an understanding that these are the only variants, and having a basic understanding of them would suffice. Well, to a very great extent, having a basic understanding of them would suffice. But when you would want to work as a data scientist or probably as a data analyst, uh, you would have to know which chart to use when, because there is a lot of varieties of graphs. Just to give you a small idea, we have around 30 to 40 graphs. Like, we have a pie chart, we have a mosaic chart, we have population pyramids, we have spider charts, and you have flow charts, stock charts, you have Gantt charts. So guys, the number of charts is unlimited, and all that you'll have to do is to start working on each of them, and even before that, start having an understanding of the basic variants of plots first, and then probably we could go to an understanding about the others. So here you have some more plots. This is a multiple line graph. This is a pie chart. As we just discussed, pie chart is a segmental breakup of a circle. And when you work on pie chart, you would be able to understand how is it divided in one unit or in one quantity of 100, or probably, whatever is the split that you're taking. This is a vertical bar chart. This is a bubble chart. You have multiple line graph. Area graph is something that we would look at right now in one of the examples, probably, or probably we would look at this in video one or video two. And this is the video one of data visualization, right? So without wasting time, yesterday or probably in the last session, we saw how to work on Anaconda Navigator, and today we'll just touch base upon Spider, and we'll quickly move on to Anaconda Navigator, and we'll understand how to work on different types of plots and graphs. So without wasting time, let us move on to the platform. Oops. Okay, so all that's deleted. Now guys, this is your Spider platform. Now, as you're able to see, your Spider platform has three parts. You have your console, or you have your data variable explorer. Okay, this is here. All right, you have your help. This is for your plots, and these are your files. All right, now if you might want to import any of your data set, you can do that from your files. This is the place where you would be having your output, or you can check your execution. This part here, when you click on this, you'll be able to access your history. And just to ensure that you people are on the double side sure, our studio and Spider, both of them look or function almost alike. All right. Though our studio is for our language and Spider is predominantly for Python, though it can be used for many other languages. But though predominantly it's for Python, as you can see, Python 3.7. All right. Yes, the interface, it looks pretty much alike. All right. But when you talk about Anaconda Navigator or probably Jupyter Notebook, we know how it looks. It looks a bit dry, but one advantage here it is the most lightest, or probably a very lightweight UI. It's got a very lightweight UI, and it can perform everything that Spider, or that this tool can do. So there is in fact no difference, either if you want to work on Anaconda Navigator, or either if you want to work on Spider. So yeah, this is how, or this is the way how Spider looks. All right, so here also you can do almost everything that we do 2 plus 3, and when I execute this, you can see you would have everything, it runs just the way it should. There wouldn't be any errors. All right, and when you save this value into, okay, now this is uh, Python. Now when you save this value into G, all right, and when you would want to execute, you can still execute and check. All right. So guys, Spider and probably Anaconda Navigator are just the same. Now here, the only difference between Spider and Anaconda Navigator is when you work on them, I'm sorry, I mean to say when you work on them, as in when you work on any Spider application, right? Your file would be saved in .py format, and when you work on Anaconda Navigator using Jupyter Notebook, your file would be saved in IPYNB format. That's the only difference. See, this is .py. If you can see, let me just highlight this for you. Here, this is .py. All right. Now, there's another difference, or there's another very important step that I wanted to mark before we go further. The difference between coding in R and Python, or probably R versus Python, is just for you to know, or just so that you don't get confused. Now, when you're working on R, it doesn't matter even if you save it like this, or even if you save it like this. But when you're working on Python, it's important for you to start it with a variable. Doing it other way around will throw you an error. Let us just check and cross verify on that statement. I think we've just done that, but just to be double sure, let us. This is how it was earlier, and when you try to execute this, you'll see that it will give you an error saying that it can't assign to an operator. All right, because this way seldom works in Python. All right, so guys, it has to be the other way around. And once you're done with it, you can save this file, and you can save it with the whatever name you want and whatever is the location that you have. All right, so this is how we work on Python using Spider. We'll just touch base upon Spider in another video for data visualization, but in this video, let us now move on to the Anaconda Navigator app, wherein we're using Jupyter Notebook so that we understand data visualization. All right, so guys, let us now jump to that. And in the meanwhile, let me just remind you that if you have any queries, I literally mean if you have any queries, then please feel free to ask us in the comment section below, and I would get back to you on that. Probably, if not immediately, I would get back to you on that probably at some other point of time. So if you have any queries, I would request you to drop a message. So now here, let us understand three types of graphs. The first one is line plot, the second one is histogram, and the third one would be a bar plot. So let us start working on each of them. All right, so here, as you can see, I've come up with a small note that is about data visualization libraries. So here I'm using different kinds of libraries like Matplotlib, ggplot, Seaborn, Plotly. All right, though I'm not using all of them right here. I'm just trying to state, or I'm just trying to name different libraries that we have in the field of Matplotlib, or sorry, in the field of data visualization, right? So here, when we use Matplotlib, why do we have to use Matplotlib is definitely the first and the most important question that you all might have. So as we've already answered that right at the beginning, it works, great when you have dependent libraries like Pandas and NumPy. So Pandas, NumPy, and Matplotlib, they all go hand in hand. The next one is it provides great, interface for object-oriented APIs. That's the second thing. And also, you can perform almost all these variants, that is line, bar, scatter plot, histogram, image graph, box plot, violin plot, and all of these can be performed when you're using Matplotlib, stream plot, quiver plot, area plot. Now, the next assignment for you, or probably the next challenging task that I have for you is Whenever you find time, guys, please go through each of them. I would request you to again, pause the video for a second, note these types of point, plots that you have, if in case you've never heard any of them, or if in case you've not heard any of them before, or even if in case you forgot, any of the, in any of these cases, I would recommend that you strongly make a note of them and then go back to Google once the session is over and just try understanding how each of these plots is important. All right, so now starting with line plot and understanding how we work on it, the first thing comes first here. The most important thing that we have is the library. And when you're talking about a library, guys, you have to import numpy, which is the most important, right? Now whenever you import numpy is a dependent library, all right, or numpy is an independent library, but numpy has many dependent libraries in itself, all right. Or you can also say that there are a lot of other libraries which are dependent on numpy, all right. Either which ways, the understanding still remains the same. Okay, the second part is importing matplotlib as pyplot, all right, and as PLT. Now, when here you talk about PLT is again a standard convention. You can import this as XYZ and you can import this as ABC as well, but you generally do not do that, all right. It is as discussed, it is a standard convention that we generally use the term PLT, all right. Now when you're using matplotlib.pyplot as PLT, the next most obvious statement would become this one, which is percentage matplotlib.inline. This is also referred to as the magic function, and this is to ensure that your graph is very neatly arranged in the line below. All right, because earlier when we, it was pretty earlier when we were working on Python interfaces, we had these kind of graphs which used to come up on other window. All right, another window or another tab used to get open when we wanted to check a graphical interface. But nowadays, thanks to this magic line, we have that avoided. All right. Now, what we're doing is I'm just trying to come up with a very small and a very simple kind of line plot. All right. And here, as we know, every kind of graph or a chart requires some kind of an axis, right? And as long as it is a 2D graph, X and Y axis are a mandate. So here I'm considering my X axis to be a range of numbers wherein I'm arranging numbers from 0 to 10 with an interval of 0.1. And then I'm taking my y-axis with an equation that is 2 into x plus 5. Now you can change these equations to whatever you want. All right. Now we all know what arrange does. We've already seen commands like these. This is a Python basic. This is a part of core Python, or it is a part of number library, numpy library. All right. And here I would be arranging numbers from 0 to 10 with an interval of 0.1. And I'm also considering my y-axis to be an equation which is 2 into x plus 5. So every value of x would get substituted here, and that would be the value of y, like with the intervals to go. All right, now going forward, if you can see, the next statement is I would be using plt.plot. Now guys, here the most important function when you want to use a line plot is plot. That is it. There is no separate function like line plot or line graph. When you use a plot function, you would automatically be having a line graph only. And for example, when you're working on a histogram, you would be having it as hist. Here it goes, plt.hist. But when you're talking about a line graph, it is plt.plot. Now, why do we use PLT? Because PLT is directly a function of matplotlib library. All right, and then I would be using plt.show. Now, if you try giving the same command with pd.show, it would give you an output error because PD is not a part of data visualization library, and also show might not be a part of PD framework or PD library within which because of which it might throw you an error. So things like these become very, very important when you're dealing with data visualization, or probably when you're dealing with any library. It is very important for us to know that if you're working on a library, what are the core basic features that you have within a library. And if you want to understand any of them, guys, all that you have to do is please go to the internet. So we are here right now, and you can just probably type in how to uh, understand. No, okay, guys, we don't want to check about girls. We'll talk about how to understand. Uh, it's not pandas. We were talking about matplotlib. So it is matplotlib. So we'll be checking about how to understand matplotlib. So we'll skip all these. We'll go to the most important page, that is matplotlib.org. Guys, now every time, or probably each and every time you want to work on any library, you would be having a website of its own. Now, just to give you another example, let me open up Google, and when I open Google, I can also check for pandas. I can just type in pandas library, and when I do that, you have pandas.pydata.org. So let us just open this. So here you go. So here you have install pandas, how to get started, and pandas is with the support of RStudio, so you can use pandas in RStudio as well, in Ursa Labs, Anaconda, and that's exactly where we are using currently. Okay, and Shan Zuckerberg initiative, I don't want to talk about this right now. Well, then you have PyPlot. The same is for PyPlot. As you keep going further down, you should be able to see how to work. See, download source code pyplot.py, download Jupyter Notebook pyplot.ipynb. And here, when you work on this, you have different examples that are given here. How to work on multiple plots, how to work on a sinusoidal wave, all right, how to work on plots and subplots. So everything that you can probably think of, this is a histogram, by the way. All right, everything you can probably think of, you will find them here. See, here you have a plot. Now this plot, again, if you want to check about it, you can see what would a plot do, and everything about a plot. All right, so this is the most authentic website if you would want to check about anything. It could be anything. So here you have examples. Now when I click on examples, it'll show you what are the different kinds of plots you have. Everything very neatly arranged. Right, guys? So this is how you can use this library. Now the same applies to this also, where you can either use this or getting started. And when you go to getting started, you will be having how do you want to work? You want to work with Anaconda, then this is how you work. All right, you is if you're working with pip, it is giving you different. See, these are so it gives you a very detailed subset of each and everything, very neatly arranged for every user to understand. It could be a fresher, or it could be a person who's already good with data set, or it could be a person who's just learning. Either which ways, you could use these libraries for a great number of purposes, or for a great insight into authentic learning. All right, now notwithstanding these libraries, let's go back into bar plot. Now that we have understood line plot, it is now complete bar plot. So here, as you can see, I'm importing numpy as a library, import numpy as np, import matplotlib.pyplot as plt. And by the way, guys, just so that I keep you also informed, most of the examples that I work with are from authentic websites only. I take them, I modify them, I probably make them a bit easier if I find them a bit complex for a beginner to understand, and that's exactly what I discussed. So all these codes which you are referring to here can be practiced even when you go into your Matplotlib library, because that is the most authentic website that you have if you want to go ahead and work. All right, then next one you have is creating a data set. So here I'm creating a data set with the name data. I'm considering four variables or four fruits here with their quantities. You can also call this to be a dictionary if I'm not wrong, right? So this can also be called as a dictionary because it has a key value pair. All right, now what I'm doing is I'm taking two more variables with the names to be names and values, and I'm passing my key into names and values into values, and then I'm plotting. And when I want to plot a bar plot, I would be using plt dot bar, and this is how you give a figure size. Plt, which is a function of matplotlib pyplot, and here I would be using dot figure. And within this, when I give the dimensions, it would be taking this for width is to the height. And then I would be giving my x and y values. X would be names and y would be values. And now let us just scroll this to understand. So you have names on your x-axis and values on your y-axis. So I have a highest quantity of lemon and my least quantity fruit is oranges. So now if someone asks me what is the fruit that I would want to invest on to fill up my stock immediately, then I would want to probably use this on oranges. Or I don't know, you can come up with n number of assumptions based on this graph. Going forward, this is another variant of graph, and this is horizontally arranged. And the only difference that you can see here is there is no labeling here. You don't have the name of your y-axis, you don't have the name of your x-axis, or things like that. Like we do not see that there's a title associated for the plot. But now when you go forward, we have added all that. So here there's a different set of fruits, that's lychee, lemon, tomato, and banana, and their values associated. So you can see very clearly I have a huge quantity of lemon here, that's 30, and I've arranged them with key value pair for name, within names and values. Now that this is done, in my next step, I'm taking plt.figure. I'm arranging my figure size in 10,5 ratio or 10,5 value, and then I'm using bar h. Now bar h is a bar graph horizontally arranged. All right, and I'm taking the color to be orange, and here if you can see I'm using plt.title, which is to name my plot. So you can see bar plot demo, which is exactly this name which you have here, and then I'm taking my x label and y label to come up with fruits and quantity. All right, so now going further, we have histogram. All right, and here when we are working on a histogram, the steps remain the same as you can see. The only difference is in your data set A and B in your function's name. Otherwise, there's no huge difference between the coding sequence or between the coding patterns of a histogram or a bar plot or probably a line graph or any of these. They're not very different from each other. All right. It's all about this one word plt dot that makes the difference. So now here, the two libraries that I'm considering, okay, the library that I'm considering is same, NumPy and probably Matplotlib, that's it. And after this, I'm considering a list of numbers, 10, 12, so you can see they're just randomly arranged. In my step 3, I'm considering a histogram and I'm passing my data, which is numbers. So this data is what would go here. Now, as you can see, one of the best thing here is there's no necessity for me to go with X and Y axis, like this is my X axis and that's my Y axis. Because whenever you're talking about a histogram, right, all that matters is about the bins. Because in histogram, you would most obviously be working with numbers only. All right. So that is what it is. Now I am taking an edge color. Okay. Now guys, when you talk about edge color, if you can see there is an edge and I'm, adding the color to this. It's about that. And you can take color also. Now, how would you know what are the different features that you have for PLT hist? In order to do that, there is one simple way you can just come up with plt dot hist. You can do this and okay, let us just execute this command. Okay, the command's executed, and now let us do this. Okay, so if it's not here, not to worry guys, you can still go on to Google. All right, and you can do a plt dot hist. Okay, and when you do this, you can open about it and you can check things here. There is no need for you to worry, or there is no need for you to panic if there is something that's not coming up on your Anaconda Navigator on your Jupyter notebook. The most obvious step or the most obvious step that you would want to do is again go back to your Matplotlib library. See, this is the same library that we've opened. Then it is the same matplotlib.org, and we are on the same website here also. It's matplotlib.org. Anyways, so here you can see these are the different parameters, or these are the different functions or properties within plt.hist that you could use. Bins is something that we've used. Range is something that we have. And you can also see that we've used density, cumulative, align, orientation. So there are a wide number of options that you have to choose from within properties. And if you ever wonder what is the use of these properties, or how would these properties, be of any help, then the most important understanding here is when you use any of these properties, they would enhance, or they would ensure that you can come up with a graph which is of your choice, and not a graph which is just available. All right. So here, anyways, notwithstanding this, and guys, if you would want to search for help in Anaconda Navigator for any of these, or for any of the library, all that you'll have to do is enter the name of the library that you imported. Like if it is Pandas, you could do it as PD. Now let us assume that you would want to check about merge. Okay. So let me just import Pandas as PD. All right. And when I do that, let us, okay, it's not a hist, it's pd dot merge. Okay, and when you do that, guys, you should, ideally be able to see things about merge. All right, so here you have merge. Okay, I think I was applying the brackets there, which was my fault. So here you can see you have everything about merge. All right, and likewise, let us just go back and let us now also check for plt dot hist. And I think ideally we should be having the required signature. So here you have all the features that you could use. And now you can, just scroll down and cross verify. We have used title, we have used X label, we have used Y label, we have used grid. Now all these are features of Matplotlib. But what are the hist? So we have used edge color, we have used color, we have used bins, and X is the data. So X is numbers, right, guys? So here, if you're seeing this X, X is equal to numbers here. The next one is bins. We have used pins for every 20 numbers, or an interval of every 20 numbers. And then you can see we have other features as well. You have color, which we have used. All right, COLOR, and then even edge color can be used. I think it is somewhere in there. So, and here, as you keep going further, you can see there are different properties, or there are different features. There's description about each of them. So here, when you use hist type, you can select what type of histogram you want it to be: bar, you want it to be bar stacked, you want it to be step histogram, you want it to be step filled. So guys, each of these is meant for different purposes and would give you a different understanding. And it is very important, and also it is actually mandatory for you to understand all these when you're working real time. Because when you work, or forget working, when you go appear an interview, in most of the cases, if you are experienced between 1 to 2 years, you would be asked on questions like these. That's difference between different types of graphs and plots. And how would you align different plots and graphs? What is the orientation of different plots and graphs? And what's the color? Or I mean, color is the last question that they would probably ask. But yes, you would be having questions based on properties also, because that is how they would cross check if you have knowledge in detail or not, or if you have knowledge which is profound or not. All right, so guys, I have explained what is line plot, how do we work on histogram, and how do we work on bar plot, and also how do we understand how to check different libraries from authentic websites. We've also seen and understood how do we work on spider, which is another UI, or which is another interface for developers to work on Python. So I hope you have now understood the importance of plots and charts, and how do we work on them, and also what are the different libraries associated, and also what are the different dependent libraries associated for different kinds of charts. So right guys, so just to give you a recap, we have seen, or we've covered data visualization, we've covered spider, plots, and then we've moved on to hands-on. So I really hope you understood and enjoyed watching the session. And if in case you did, and if you feel that this video has been of any use to you, then guys, please do not forget to hit the like button, because that would encourage us to do further. And also do not forget to subscribe to our channel, because the moment you subscribe to our channel, you would be having access to a plethora of videos. And also do not forget to hit the bell button, because the moment you do that, you would be having notification whenever we are up with a new video. So guys, stay tuned, stay subscribed, do not go anywhere. This is me, Varun Rao, signing off, wishing you all the best and a great day ahead.